Okay, so we're still discussing resolving forces into its components. So let's do a question on that. A lamp is supported in equilibrium by two chains fixed in 2 points A and B at the same level. The lengths of the chains are 0.3 meters and 0.4 meters, and the distance between A and B is 0.5 meters. Okay, so there's 2 points A and B, probably on the roof. And from these points, a lamp is being supported. So let's say this is the lamp. Okay. And then we're told that the lengths of the chains are 0.3 and 0.4 meters. So let's say this is 0.3 meters and this is 0.4 meters. And the distance between A and B is 0.5 meters. Okay. Given that the tension in the longer chain is 36 newtons, so I shouldn't have drawn such a huge lamp because then it's not looking like a triangle. Lamp can be represented by a small dot as well. Okay, so here's the lamp. Now it's looking more like a triangle. Okay, and then it says that the tension in the longer chain is 36 newtons. So I'm going to, this is the longer chain, and the tension is facing, it always faces away from the object. So here's the lamp. So the tension has to face upwards, point upwards, and this is 36 newtons. Okay. Show by resolving horizontally that the tension in the shorter chain is 48 newtons. Okay, now you have to show that the tension in the other string is 48 newtons. Okay, so we need to resolve the forces. So the only force we have is the 36 Newton force, and let's call this force T Newton's force, that we have to show that it's 48 Newtons. Okay. It says by resolving it horizontally. So that means we only need the horizontal component, not the vertical component for now. So we need the horizontal component of the 36 Newton force, which will be pointing in this direction, because we discussed it yesterday, that if a force points in this direction, then it should have a component in this direction and a component in this direction. So this horizontal component is going to be 36 cos theta. But what is theta? This is the angle theta, right? And from alternate angles, this is that angle theta. Because this is a horizontal surface and this is a horizontal line. So they make parallel lines, and angles between parallel lines forming a Z-type shape make alternate angles with each other. That means they are equal if these two lines are parallel, which they are in this case. So these two angles must be equal. Now we need to find size of this angle. What is going to be this angle? So how do I find this angle in the triangle? Anybody?
मैम सबका स्क्वायर लेना होगा और एक मिनट मैम मैं जरा देख
Okay. बाकी भी सोचे. How do we find this angle? Because I need this angle to resolve the 36 न्यूटन फोर्स। इसके बगैर तो रिजॉल्व नहीं हो सकता। तो दो तरीके हैं। एक तो कोसाइन रूल।
मैम कोसाइन रूल।
हाँ, कोसाइन रूल हो सकता है। Sorry, I have a very bad cough going on. So cosine rule could work. So remember cosine rule from O levels? This is theta.
C square equals to
Hmm.
square root A square plus B
Yes,
square minus
exactly.
2AB.
Exactly. या तो वो कर लेते हैं. So it would be you start with the side opposite to the angle. So you start with 0.3 square equals 0.5 square plus 0.4 square minus 2 times 0.5, 0.4 cos theta. Now you have to make cos theta the subject. So that means first make this the subject. So move everything else to the other side except for this term. So 0.3 square minus 0.5 square minus 0.4 square equals minus 2 times 0.5 times 0.4 cos theta. Now you have to make cos theta the subject. So move everything to the other side again. This time it divides upon negative. Do not make it positive. Being multiplied on this side, when it goes to the other side, it divides. It does not become positive. So minus 2 times 0.4 times 0.5 equals cos theta. And then you take cos inverse. Okay, what do we get when we take cos inverse of this?
0.6 एक मिनट
आपने रेडियंस में तो नहीं किया हुआ? देखो,
मैम रेडी
नहीं डिग्रीज में जाओ.
मैम 36.869.
ठीक है, 36.869. So keep the 9 के बाद फिर से 9. So keep the longer answer. So it's going to be 36.8698. ये हो गया. Okay. So this component is 36 cos and then 36.8698. Okay. Now we're going to look at the component of T, the other tension whose value we have to find. So its horizontal component is going to point in this direction. And it's going to be T cos, let's call this X, angle X. So this is going to be angle X and this will be angle X. Now you need to find angle X. So let's do that. Again, we'll have to apply cosine rule. Now we need, or you can also apply sine rule this time.
Ma'am,
This is X. This is 36.8698. This is 0.5. This is 0.3. This is 0.4. So you may apply sine rule as well. So 0.4 over sine X equals 0.3 over 36, sorry, sine of the opposite angle, sine 36.8699. Cross multiply, make X the subject. So you should get sine inverse 0.4 upon 0.3 into sine 36.8699. Okay, what do we get?
Ma'am, 53.130.
Okay. So it comes out to be 53.130. Okay. So this is 53.180. Okay. Now I'm going to equate the horizontal components. Since the system is in equilibrium, it's not moving. That means the right side forces are balancing out the left side forces. So they need to be equal. So T cos, what angle did we just get? 53.130 and use one more decimal place, 1 equals 36 cos 36.8698. Now make T the subject and tell me if we get 48 newtons. Do we get 48 newtons?
Yes, ma'am.
Okay. Yes, we get 48.001, which rounds to 48.0 in 3 significant figures. So we've shown that the tension in the other string comes out to be 48. Okay. Okay, so we actually made the question a bit harder than it had to be. Now I'm going to show you how we could have done it without applying cosine rule. Okay, if you notice the sides of the triangle, they are 0.5, 0.3, and 0.4. If you could recall from O levels that this triangle is a right angle triangle. 4, 3, and 5. This forms a right angle triangle because 5 square is equals to 4 square plus 3 square. So 25 equals 25. So since we can apply Pythagoras theorem on it, so it's a right angle triangle, and these are the most commonly found lengths of a right angle triangle. These are also consecutive, 3, 4, 5, and also they satisfy the Pythagoras theorem. So this is a right angle triangle. Also, all of their multiples also form right angle triangle. For example, if I times every side with 2, so this becomes 8, this becomes 6, and this becomes 10, even then it satisfies the Pythagoras theorem. It's still a right angle triangle. Similarly, if I divide each side with 2, I get 2.5, 2, and 1.5. It's still a right angle triangle. Because if you apply Pythagoras theorem on it, you will get left hand side equals right hand side. So the given triangle dimensions also show us that this is a right angle triangle because this is 0.3, this is 0.4, and that's 0.5. So this also is a right angle triangle. So that means that there's a 90-degree angle here. So this is a right angle. Now, if it's a right angle triangle, finding theta and finding x becomes a lot easier. So To find theta, I can use sine, cos, or tan, since we have all three lengths. So if I use sine theta is equals to perpendicular 0.3 over hypotenuse 0.5. So theta would be sine inverse 0.3 over 0.5. It will give you the same answer as before. Instead, what the marking scheme does is that it doesn't use theta. It directly uses sine theta. Because when you're resolving components, you need sine theta and cos theta. So it's fine if you don't have theta. You can still use the entire sine theta. So if you know sine theta is 3/5 and cos theta is 0.4 over 0.5, which I can write as 4/5. So I would know that this component is 36 cos theta. So instead of cos theta, I'm going to use 4/5. And this component would be 36 sine theta. So instead of sine theta, I can use 36 3/5. So now the advantage of this method is that I don't have to use long decimal values. I can just use the fraction. Okay. Similarly, we need cos x and sin x because we also need to resolve t into its component. So cos x sin x would be or some people have, that's 4/5. It's actually 0.4 over 0.5, but we can write it as 4/5 if you multiply 10 both with the numerator and denominator. Similarly, cos x is 0.3 over 0.5. That means 3/5. Okay, so I did not find the actual thetas by taking sine inverse or cos inverse, or the actual x by taking sine inverse or cos inverse. Instead, I'm going to use the exact value of cos theta or sine theta, the fractional value. Okay, so now back to the first part where you have to find tension by resolving the force horizontally. So this is T cos x. Yes, this is T cos x. And the other one was 36 cos theta. They should be equal because the system is in equilibrium. It's not moving. So T cos x equals 36 cos theta. Okay, so we know cos x is 3/5. So T 3/5 equals 36. Cos theta is 4/5. So T comes out to be, I'm canceling 5 and 5. So 36 times 4 over 3. 48 newtons. Same answer as before. It's now an exact answer. Earlier, remember, we got 48.001. That was because we were rounding off the angles. We were rounding them off to 4 decimal places. There were actually more values after those 4 decimal places that we were not accounting for. That's why our answer was not exact. But now, instead of finding theta and x, we found cos theta and sine theta and cos x and sine x. And we'll use the entire fraction now, instead of using a rounded theta or a rounded x. Okay. So this is the part 1 of the question where we have to find the tension in the second string. Next it says, and find the mass of the lamp. Okay, so mass is going to point downwards. And we will say that's 10 M force acting downwards. So there should be a 10 M force. But countering that are 2 vertical forces One of them is 36 sine theta, and the other one is pointing upwards, which is t. T came out to be 48, and this one will be sine x. So now we're going to equate the vertical forces. This force plus this force equals this force. So 48 sine x plus 36 sine theta equals 10m. 48 sine x is 4/5 plus 36 sine theta is 3/5 equals 10m. Please find m from here. What do we get? The answer says it should be 6 kgs. Are we getting 6 kgs?
Yes, ma'am.
Okay. Yes, we get exactly 6 kgs. So m is 6 kgs. Okay. So in some of the questions, you have to first find theta. And it's most likely going to be a 90 degrees angle. There's actually a very little chance of needing to apply cosine rule and sine rule in mechanics. There might be a need to do so in pure papers, but mechanics में ये लगने के बहुत कम chances होते हैं. So पहले check किया करो कि the triangle that we're dealing with, is it a right angle triangle? Okay. अच्छा जी, I'm giving you another question. Okay. Question is, a paraglider of mass 9 kgs. Here's a paraglider. Its mass is 9 kgs. Is pulled by a rope attached to a speedboat, with the rope making an angle of 20 degrees to the horizontal. The paraglider is moving in a straight line parallel to the surface of the water. Okay. So there's a rope attached to it, making an angle of 20 degrees with the horizontal. Okay. So here's the paraglider. Then a rope attached to it, making a 20-degree angle. Okay. And he's moving in a straight line parallel to the surface of the water. So its movement is in this direction. And that means it's moving in a straight line parallel to the direction of the water. Okay. With an acceleration of 1.2. So the acceleration is 1.2 meters per second square. Tension in the rope is 250 newtons. Okay, so tension in this rope is 250 newtons. Tension always points away from the object. So it's going to point in this direction. This is the tension of 250 newtons. Okay. Calculate the magnitude of the vertical lift force acting on the glider and the magnitude of air resistance. Okay, before we find that, let's first resolve this force. So the force will have a vertical component and a horizontal component. So let's consider this as our triangle. So it's going to have a force acting downwards, a component acting downwards, and then a component acting towards the right. By the way, you could also consider this as your right angle triangle. That would be absolutely fine as well. Right and down. This would be fine as well, or this would be fine as well. So it's up to you whether you make the triangle above the hypotenuse or below the hypotenuse. So if it's below, it's down and left. Okay. So we know the 20-degree angle, so we can resolve the force. The one opposite to the angle is the sine component. So this would be 250 sine 20. And the other one is 250 cos 20. Okay, these are the two components. They're actually acting on P because the tension is acting on P. So you, instead of making this here, you can also make this here. It would mean the same thing. So you can also bring this up. This is 250 cos 20. Okay, whenever you're resolving a component, you can resolve it like this and this, or you can also resolve it like this. It doesn't matter whether you're making that arrow here or here. Okay, so I'm just going to keep it where it is originally. Okay, now it's asking, calculate the magnitude of the vertical lift force acting on the glider. So there's some force pushing the paraglider upwards. So that's going to be the contact force. Calculate the magnitude of the vertical lift. So this would be the vertical lift. An upward force. It's called force vertical. So this is the vertical lift force. This is what we have to find. So it's an upward force. So opposing it, there's a force downwards, which is 250 sine 20, the component of tension. Also opposing it is the weight. So there should also be another force acting downwards, which is going to be mg, which is going to be 900 newtons. Okay. So the up and down forces cancel each other out because the paraglider is not shooting up into the air. He's moving in a vertical direction. There's no change in his position on a vertical level. So the vertical levels, the vertical forces are actually balancing each other out. That means that the force of the vertical lift should be equals to the two downward forces, 250 sine 20 plus 900. So that should give the vertical lift, which is 250 times sine 20 plus 900. That's 985.505. So that's 986 newtons. Next, we have to find the magnitude of air resistance. Now, if the object is moving towards the right, as indicated by the double arrows, then the resistance should be in the opposite direction. So this is the force of resistance or the magnitude of air resistance. Okay, so that is pointing leftwards. Towards the right, we have 250 cos 20. So we're going to use forward force minus backward force equals MA because there's a motion in the horizontal direction. So forward force is 250 cos 20 minus backward force is the frictional force equals MA. M is 90 and A is 1.2. Solve this equation to get the force of air resistance, FR. Tell me what you get.
$224.1 newtons.
That's not what it says here. It says that it
That's
should be
126.
126.9. Alia, recheck.
Okay.
Should be 126.9 newtons.